Let us look at few more operations on an array, like inserting in a sorted array. We want to insert a new value in a array which is already sorted. So we should add a new value at a sorted position. The next one is checking if an array is already sorted. Then one more, arranging all negative elements on the left side and positive elements on the right hand side. So let us check these. So these are few simple operations, but that are important operations. So let us check how to perform them. Now the first operation, I want to insert a new element 18 in this array, and this array, if you observe, it is already sorted. So in a sorted array, I want to insert a new element such that it is inserted in its sorted position. So where this 18 should come? So if you check here, it is greater than 4, greater than 8, greater than 13, greater than 16, but less than 20. 18 is less than 20. So 18 should come here. This is the place for 18. So I have to insert 18 there, but already some number is present there. So I have to shift the element and make free space for 18, then only I can insert it. So for shifting, I should start from last element. I should shift 33, then 28, and 25, then 20, then I'll get a free space, then I can insert this one. Now let us look at the exact procedure. For inserting a new element 18 in this list, I don't have to find out its position by checking these numbers. I can simply start checking this number by the last. I can simply start checking this number from the last number onwards. If those numbers are greater than this one, I can shift them. If suppose this is not 18, this is 38, so this is greater than 33, so I can simply store 38 here. But this number is smaller, so I can start shifting them. So 33 has to be shifted, and 28 has to be shifted, and 25 has to be shifted, 20 is also shifted. Then this number is 16, so 16 is smaller than 18, so the next place is 18 only. So I can insert 18 here. That's all. This is the procedure. The important thing that we have to observe here is that you no need to find the position of this element by comparing these elements, because after comparison also you have to shift them. So directly start shifting them. Now let us see the procedure how I can shift the elements and I can insert this new element. Let us call this element as x. So let us say it is 18, for example. Then I should start shifting from last. So from here I should start. So let us call that I as length minus 1. That is, length is the number of elements in the list, that is 8. So 8 minus 1, that is 7. So I starts from 7. Now repeatedly what I have to do, I have to go on shifting the elements. So I have to go on shifting the elements, so that is while loop I will do. How to shift an element is this a of I should be copied at a of I plus 1. So a of I plus 1 should contain a of I. So I have to shift. This shifting has to be done repeatedly. How long? As long as this x is smaller than that element. If this becomes greater, then I should stop. If this becomes greater or equal, I should stop. So as long as a of I is greater than x. And after shifting an element, I should also decrement I, that is decrement I. So I minus minus. So using while loop, I have written the code. Even I can use a for loop also, but for loop is useful when you know how many times you are going to repeat, and while loop, we don't know how many times we are going to repeat this one. We have to repeat based on the condition that this element is smaller than the element, then shift it. So I have used while loop. Now once this has finished, so if this loop is executed, then it will move 33, then also 28, then 25, then 20. Then when it comes here, it will stop. I will stop here because this element, that is a of I, is not greater than 18. So this is not greater than 18, so it is false, so it will stop. So where I should insert this new element, I plus 1 place. So at a of I plus 1, I should insert element x. That's it. This is the pseudocode for inserting an element in a sorted list, and it is one of the important procedures. Now let us move to the next one, checking whether the list is already sorted or not. Let us see how to check whether a list is already sorted or not. Here as an example, already I have a sorted list with me. So the procedure for checking whether it is sorted or not is start from this one. This is smaller than this, and this is smaller than the next number. This is smaller than the next number. So every present number is smaller than the next number. Then it means the list is sorted. If suppose here I have 26, then 4 is smaller than 8, 8 is smaller than 13, 13 is smaller than 26. Yes, up to here is correct. 26 is smaller than 20. No, wrong. So it means the list is not sorted. So the procedure is check the current number with the next number. If it is smaller, go on continuing. And if you have reached the end of a list, so finally in the procedure, we will check the current number is smaller than the next number. If not, then it is not sorted. If we have reached at the end of a list by comparing this, means it is sorted. I will write like an algorithm. Let us see. Algorithm is sorted. I am calling the algorithm as is sorted, and it takes an array and the number of elements. Now we have to start checking from first element next, then next, so on. So until where we should continue, we should stop here, because we cannot compare 33 with any other number, right? So let us say there are 8 elements. N is 8. This is 8. So we should stop here. No, we have to stop before this one. So we should stop at -2 place. So using for loop, we can do this one. So for I takes values 0, I is less than number of elements. No, usually we reach till here when we say n, but we have to stop before that. So n minus 1, I plus plus. Then in this, what we have to check for? Is there any pair of elements where the first one is greater than the second one? It means the list is not sorted. So we'll check for false condition. If a of I is greater than a of I plus 1, any number is greater than the next number, then return false. Means list is not sorted. We got this condition satisfied, then we return false, means list is not sorted. And that's all, end of loop. If we have completed the whole array, complete array, and we never came across such a pair of elements, we have finished the array, means list is sorted. So from here we can say return true. That means list is sorted. So if at all anytime this condition is true, it will stop and say false. Otherwise it has reached the end, then it will return true. So in this case, it will check I with I plus 1. This is not greater, continue. This is not greater than this one, I or I plus 1. This is not greater than that one, continue. This is not greater than next one, okay, continue. This is greater than this one. Yes, this is greater than this one. So return false. If suppose this is not 26, this is 16 only. Now it is completely sorted. So it will check this one with this one, right? So this is not greater, then this is not greater than this one. This is not greater than this one. This is not greater than this one. This is not greater than, not greater than. So till here it will check not greater. So here it will stop, come out of the loop and say true. So your list is already sorted. So this is also useful, like before sorting the elements, to confirm if they are sorted or not, we run this procedure. So how much time this procedure is taking? It is iterating through all the list of elements, then it is taking order of n time. If the list is sorted, it will take n. If it is not sorted, then it may stop at any place. That is minimum one comparison it performs. So minimum time is constant, maximum time is order of n. Now next we will see negative numbers on one side, positive on other side. Now the next problem, we have an array or a list which is having positive as well as negative numbers. This is an example list. It is having mixed positive as well as negative number. What we want to do is, we want to bring all negative numbers on left hand side, then followed by that we should have positive numbers. So in the beginning of an array, we should have all negatives. Then when negatives have finished, then positives should start. So, but they are mixed. So how to bring them at one place? Let us see how we can do it. So for this, we can take two pointers, that is index pointers. One is I from the beginning of a list and one is j from the end of a list. So I from here and j from here. Then using I, we look for positive numbers. If there are any positive numbers this side, let us send them there. And with j, we will find out if there are any negative numbers on this side. So let us send them here. So I will try to find positive number and j will try to find negative number. If found, they will exchange. So I will also simultaneously write down the code. I is starting from 0 and j is starting from length of a list minus 1. That is from there. Then what we have to do? Check, is it positive? If it is a positive, then we have to send it there. No, this is negative. So move next. Is it positive? Yes, we got the number. So it means I should continue incrementing until it reaches a positive number. So if it is negative, it should just move ahead. So I can write while a of I is less than 0, continue I plus plus. So when the number is negative, let I move ahead. If it is positive, it stop. So yes, we got positive. Then same way, j should be decremented until it gets a negative number. Is it negative number? No. Is it negative number? Yes, stop. So means j should decrement if the number is positive. It should stop if the number is negative. So while a of j is greater than or equal to 0, j minus minus. So if it is less than 0, it should stop. So yes, we got the numbers. Then what we should do? Interchange them. These numbers should be interchanged. So thus minus 4 is brought here and 3 is sent there. So we should swap them. So I will write down swap a of I with a of j. Now I should do the same thing. I plus plus. Is it a positive number? No. I plus plus. Is it a positive number? Yes. So this loop has finished. Then decrement j. J minus minus. Is it a negative number? No. J minus minus. Is it a negative number? Yes. So j is decremented until we got the negative number. Then interchange them. Interchange. So minus 9 comes here and 10 goes there. Now continue. I plus plus. Is it a positive number? Yes. The number is not negative, so I stops there. Then j minus minus. Is it a negative number? Yes. So when the number is negative, it stops. So then again swap them. So minus 7 comes here and 5 goes there. Then continue. I plus plus. Is it a positive number? Yes, it's a positive number. Stop. J minus minus. Is it a negative number? Yes, negative number. Stop. But now we will not interchange them because I has become greater than j means we have checked the entire list. So this swapping we will not do and we will stop the procedure. So this swapping is done if I is less than j. So this is conditional. So moving I and moving j, moving I, moving j and interchanging the element was repeating procedure. How long we have done this? As long as I is less than j, while I is less than j will continue. So this is the procedure for swapping the elements. So this is the procedure for arranging all negatives on one side and positive on other side. Now analysis, how much time it has taken? The time was spent on comparing the elements. So total how many elements were compared? N plus 2 elements were compared. We started from this with I and from there also we started with the j, and I has increased and check one more number, j has also decreased and check one more number. So total n plus 2 comparisons were there. Then swappings, it depends. If already all negatives on this side and positive that side, no swapping will be done. But the main time is spent on comparing the elements. So we can say the time is order of n. This is scanning the whole list just once. An exact number of comparisons are n plus 2 comparisons. Now analysis. What is the work done here? Comparing the element and interchanging them. Interchanging is happening if there is a conflict in the condition. Interchanging is happening only if positive is on this side or negative on that side. Otherwise, comparison is always done. So at most, how many elements are compared? All n elements are compared. So the time taken by this procedure is order of n only. Order of n. So that's all. These were few important operations that are performed on a list. So we have seen them on an array.